sorry, what page?
I didn't give you a page, but I will now. It's 673, figure 2721. Here's a steel framed home.
Those are skinny.
Remember, I said wood is stronger than steel per weight? It's certainly not stronger than steel per volume. Okay, if we look at those classifications. This piece of the stud right here, this will carry the same weight as that wood piece will.
But it looks like you can take your foot and kick it in.
The problem with this is buckling. That's why I kind of kept these two. This is an old one. And if you'll look at this, I'm going to pass it around. Be very careful because the edges I just cut with tin snips and they're kind of sharp. You might cut yourself. So stay away from these cut edges. This one, you'll look at the gauge on it. It's pretty obvious to the eye. This one's a little thicker. So this one I think was 16 gauge. It's a thickness rating. This one is an 18 gauge. And again, it's got some edges that will cut you. But you'll notice this guy is thinner. Now the reason it gets its strength, when you do cold rolled steel, the strength we've got to get rid of is the buckling force. So when I put weight on here, it doesn't buckle this way, right? And just snaps in half. You've seen that happen with materials. Every time you put a bend in this, you reduce that, the buckling. So as long as you can keep it to where it's only carrying so much weight and they put different bends in them, this one has 1, 2, 3, 4 bends in it. This one has
What do you mean by
1,
bends?
2, 3, 4, 5, 6, 7, 8, 10.
Wait, what are we looking at? Where's the bend? What are we looking at?
Okay, I'll pass it around. So every time you bend this, so look in here, you'll see a bend.
Yeah.
Look here, you'll see a little bend. That then gives you more surface area to resist the buckling. Okay. Now, so I'll kind of pass that around so you can see it. I'll get this one to you. Now these have a problem too, and now these are tough to join things with. How do you put a door on this or a window? They're made such that you can take this guy and you just snap them right in. And you kind of get this. And they'll just snap right in there, and then you can use this around your frames.
Is that called furring? Is that what the furring is?
Well, yeah, I would call this furring for a steel wall. Here's this other one, Mary, if you want to compare the two before you pass them on. So those little knockouts in them are for electrical and plumbing, what's going on there. Now you can use those. A lot of people shied away from them. Believe it or not, the reason I heard was they thought, I can't get radio reception in there. But that's not true at all. Mostly the reason we don't use this is really in commercial wall formation, this is the preferred material. It never changes shape. They're galvanized so you can lay them out in the mud for 2 years and then pick them up and they're going to be the exact same size. The problem with them is you need a more or a better trained workforce and you have some specialty tools. Okay, so they're more expensive to put together due to the labor. Depending on cost, I wouldn't say steel costs more than wood because that's not true all the time. Both those costs fluctuate. They are a commodity. Yes?
How do you get the sidings on there?
You screw it right to it.
You screw into it like.
Yeah, you don't use nails with this like you would with wood. We use screws to do most of our
Okay, so
joints.
now you're screwing all over. Is that reducing the buckling strength? I have that hole all over the place.
To a certain extent, but not enough to affect it. When you screw something in there, you're removing steel for the screw to go through. You're replacing the steel with the screw.
Yeah.
So it's still there, okay, for the most part. But you can use steel. Okay.
Is there many of them? Yeah.
Oh, yeah. Yeah, I've built 2 residential structures where the upper floors I use steel with.
The upper
Mhm.
is later.
No, mostly because the clients wanted to go that way. They didn't want walls where they had to come in and finish them. They wanted them perfectly straight. And so we went with that. All the walls in this building are steel studs. All of them. Okay? The ones that aren't masonry.
Yeah.
And you'll see that if you walk around. I think we do have some in some of these labs in the back area that are still exposed. And you might be able to see them through the window. I can't remember, but you could see them being done. You could also go into Google, type in steel walls. And in fact, there is a website specifically devoted to this. Where did I write that down?
So you don't have to get creative in your wiring then? I mean, you have to just follow.
No, it's
the lines.
actually probably easier. Of course, you do have some grounding issues, right? That's why they give you those cutouts and you use plastic ground. So here's a website that will give you everything you need to know about it, steelframingalliance.org. It's a good product. One thing about it, people think steel, do I gotta protect it from the elements? Yes, you do. It is still a carbon-based material. Okay, so typically we do galvanize, that protects it, but you may have to do other things also if you put it in an environment where it's in contact with the soil or moisture. It will still rust. Any questions on steel? You can use those. By the way, steel studs are dimensionally the same as nominal lumber. So if you get a 2x4 steel stud, it's 1.5 inches by 3.5 inches. Okay, so you draw them the same. Let's look at some other type of wall types. I've got two of them here that I'll kind of pass around. Let's do the first one. This is what's called an ICF wall. In essence, this is a concrete wall. A lot of the times it's used for basements. When we talk about an ICF, it stands for insulated concrete forms.
Insulated concrete form?
Yep.
Did they leave the
Obviously, you leave that.
Yep. What's that?
No, I'm just saying, obviously you leave that and you don't take the form off.
Yeah, so here's probably my favorite ones. There's a bunch of these on the market. You can just lean those wherever you want, Jed. There's a bunch of these on the market. In fact, we have a patent that came out of Idaho, and it's shown in your text. Let me give you a page for this. It is, where's my masonry stuff? I think it starts right after the concrete. Page 681 it starts. And you see the picture for it on 682 of the real product. This is called a polysteel ICF. It's a post and beam construction where it has beams and then little pieces of concrete that come through that act as beams. This was actually patented by a firm out of Pocatello. We had a plant here for a little while. This product here is called ARCS. It's the one I kind of showed you a website of the other day. This is actually out of Canada. It's now into the US all over the place. I like these the best. Polysteel has a hard time connecting. They do have connectors on the outside, but they're buried, so you can't find them. So you put drywall just screwed right into these plastic flanges. If you're on the exterior, you just put your siding or stucco or whatever right to it. Okay, so everything's done. It's got rebar clips inside for the concrete. In essence, you build these like Lego blocks. You set them down, the next one on, you look at the bottoms of them, they're perforated just like a Lego block and they stack. And then you come back and pour concrete. I've got some pictures I'm going to show you in a little bit. The nice part about these is your electrical chases are already done, your insulation is already done, it's a complete wall unit. The only thing you got to do is finish it, and it's done. So we just run everything on those. By the way, the insulation factor, wood walls 2x6, you're going to get to about an R19. These guys are R50 plus. So substantially more. We call it styrofoam. It's extruded polystyrene is the material they're using. Whenever you have air, entrained air, that's a great insulator, and that's what they use. Just to show you a few of these, so here's the one in your text. I have a whole bunch of pictures of these being built so you can see it. You'll never know these from the outside. Okay, so here's a picture. I'll kind of cycle through some pictures here. Okay, so here's one going in. You still have to come in. This is a wood frame for a door where you're going to attach it to it. But here you can see the different layers that have been built up. You stagger the seams.
Kind of like the 3 little fruits.
Yeah. Yeah, there's kind of winners I usually build in. Here's one that is quite a bit bigger. So this one's a little further along. The last picture you saw was on the back side of this back here. So here you see that this floor has already been done. You have to come in, due to the weight of the styrofoam, you can go about 13 feet high, and then you have to pour the concrete, and then you keep going. So you do it in stages. Those big things you see on the top are the supports on the inside. You'll see some more of those here in a second. Gotta go the right way here on my little mouse.
Can't change your mind on the window once you get that word.
No, the design on these, you really gotta do your upfront work. Not that you can't drill through concrete walls, you can, but it just costs a little bit more. Here you kind of see how you actually do it. So this is the finished height. Everything's framed off. This is a concrete pump truck, so you pump through the top cavity, and you do it in lifts. You kind of do about 3 feet, go all the way around, then you come back, do another 3 feet all the way around, and build them on up. Like I mentioned the other day, in the residential market, folks, this is par none the best material I've ever dealt with. And I've dealt with most of it.
Is it more expensive?
Um,
Or is it?
It's always been claimed that it is, but that's not true. Typically expect this to be from 10 to 30% more. But let me show you, we go a couple more pictures here.
Energy cost savings in one on insulation.
Where's my picture of my garage?
Is this your house?
Yeah, this is my house. For my house, I use the best material I can find. Anyway, I gotta go back. Oh, this picture. Okay, so, by the way, good help there. This garage was planned for wood, but this was right when Katrina hit and OSB went to 20 bucks a sheet, which again was last winter. I actually saved money going with concrete on this, with these forms. So again, it's a commodity, right? And you just gotta pay attention to prices. I switched it from wood to this right at the last minute because I could save money and have a better wall. Here you kind of see it being stacked up. So you stack a piece, you lay all your rebar in, put the next layer up, next layer, blah, 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 okay, to finish the wall. You get to an end on these and you can't tell the difference from this. Let me see if I can give you some finished ones. I don't know where these are at, but we kind of, if I go to the end of my little folder here, I might have some. Where are some of these pictures?
When did you build this? Last year, you said?
No, this was way back in 2000 something, early 2000s.
Oh, yeah.
You don't need to see kids.
They're cute, yeah, we do.
These pictures of them. Okay, so here's kind of the finish. Could you tell from the outside that that's all a concrete home?
No.
No, you can't. So you can make these look just like anything. Yeah, I could have bricked it, I could have stuck with it, could have done what I went with vinyl because I'm a teacher and I just don't have a lot of money. So you just make your call. But again, I really got to emphasize that if you ever get a chance to be involved with one of these, I would highly recommend it. If some of you want to build this way on this set of plans, I'd be happy to support you with it. You have another product. That's a pretty cool product. And this guy's been around for a little longer than ICFs. This is called a SIP, structural insulated panel. We actually had a plant in Jerome for a long time that did these. It's the same concept as ICFs, but instead of concrete in the middle, they use styrofoam or extruded polystyrene in the middle. And then they glue sheets of OSB on the outside. These have changed over time. This one has 7/16 OSB, but now they pretty much do 5/8. Now these are really actually, I wish they would have had some of this around when I built that last house because I would have used them for my roof. They're converting these to a lot of different aspects. They have about an R40 R factor, so they're about twice as good as a standard wall. They build chases in them so you can run all your utilities through them. What you do is you send your plans to the company, they redraw it for these. And then they build it in the plant, they ship it to you on a truck. It takes you one day you could frame a house because you're just lifting them in and bolting them together or screwing them together. So these are called SIPs, or structural insulated plant panels. The plant and drone no longer is around, but there's still, you can still get these done. Your text shows some SIPs.
I've built lots of stuff like that.
Page 672. Have you built some of these, Andy?
Yeah, but the stuff that we used was aluminum instead of OSB. So, you know, you do an adder room on a house, you can have an extra 300 square feet in a matter of days instead of, because it has all the chases and stuff built into it. It's all modular. Windows just kind of slide in and
Yeah. The big thing I think that I like about these, because, you know, I'm not sure I really like the thought of being OSB on the outside because I can't hang really heavy stuff off of that. I'd have to reinforce that. But the fact that up in like your area, in the Sun Valley area, they're now taking these and making roof panels out of them and make them whatever size you want, and they'll just crane them in and build your roof in a matter of moments, and it's all insulated for you and everything. But they're really kind of adapting this to other needs. And I think that's a great idea. I mean, you build yourself a roof like that that has that kind of insulation and you put it up in a matter of moments. Works real good with a rafter beam roof.
So it comes in sheets and then the contractors cut it?
Well, no, if they don't have to, supposedly you get all your sides, like Andy just said, it's a modular system. So it is planned and built in a factory, shipped to you, and you install it on site. Now, obviously, they're not going to get everything right. They're human. You will have to adjust some things. That just goes along with construction. Let's see. Boy, I've been going a while. I got 2 more walls. I just got our masonry walls left to do. Should we take a break or should we go into them? Keep going, Sean.
Keep going, I'm good.
Please, get done. Concrete walls, basement walls. Your text doesn't have a really good picture of this. So I'm going to the internet. Okay, so typically when we talk a basement wall, we're talking a concrete wall like this picture. Now, we have some other types of walls like stem walls, retaining walls, things of that nature. We'll get into those when we do our foundation, and we'll come back to basement walls. In essence, basement walls are just a big stem wall. The reason we use concrete for these walls is because it is down below the soil. You cannot put wood in contact with the soil. It'll rot, right away. Concrete is waterproof. It is susceptible to decay. And it is not a carbon-based material, so bacteria isn't going to eat it. This stuff will way outlast the lifespan of the building. Right? I think if you ever watch PBS, I'm sure you've seen the Roman aqueducts. Those are concrete aqueducts, and they've been around for 2,500 years, and they're still functioning. It's pretty amazing material. By the way, just so you know, maybe it's because I haven't done enough concrete work, I don't hate it yet. This is my favorite building material. Oh, these guys are workers. It mimics rock. It's heavy, hard work, but your result is good. Now, most people think it doesn't look good architecturally. We have all kinds of finishes we can do to this stuff now. And that will do a lot of things. When you're drawing your basement, I'm going to go back up here. I'm going to take basement walls with wood walls and see if I can't get a third drawing. Here's one right here. Okay, so here you see a basement wall. They've put up a sheet of insulation, and then they're sliding the wood wall next to it. Now, the wood wall is typically for 2 reasons when we come inside of a basement wall. It's 1, to join other things to, and 2, it's to provide insulation. You must protect this wood wall from the concrete. By that, it's probably sitting on a concrete floor, so it's gotta have a pressure treat base, and we'll call this out when we do sections. And then we have to do a vapor barrier or an airspace between this. Typically, most people leave a 1/2 inch airspace. See if I can't find you another picture here that actually shows that. I think this one does right here. This one shows it pretty well. Okay, so you can see that this wall, if you look at this picture down on the bottom, we got a little green board right there. That's a piece of pressure treat. That's so as the concrete's got water in it. As it leaches up, it doesn't rot that board. And then you can kind of see the shadow here that's coming off. This one, they didn't use a vapor barrier, they just left an airspace right here, so that that water doesn't come out of here and warp that wall. Okay. But you gotta do that. This is how we're going to do our wall. I asked you to draw it as an 8-inch concrete wall, right? Right here. And then I said, draw your 2x4 at 4 inches. Now, technically, you probably want to draw it at 4.5. It depends. The 4 inches is without an airspace, right? Because I got a 2x4 stud at 3.5 and 1/2 inch sheetrock on the inside. That's 4 inches. If you're going to build it where they build the airspace, it's 4.5. So that would be 1 foot, 1/2 inch. Yes?
But they didn't put sheetrock, isn't that just concrete? Or,
Well, that's why they're putting the wall
This is
up.
concrete.
oh, okay.
Then they're going to build the wood wall, and then your sheetrock's going to go on the outside of the wood wall.
Oh, right, I see,
Okay.
okay.
Yeah. And-
Not on both sides, just
Right,
on
like
one
I said,
side.
joining things to it and insulation. That's why we put the wood wall in. And of course, joining OSB, or excuse me, drywall.
And plumbing and wiring and.
Yeah, we might have chases and stuff we gotta run through it. In fact, that's what this gal's doing, right? Drilling for electrical, probably. All right, so there's all kinds of pictures in here that will show you exactly what those are. I'm gonna stop there. Leaves us an hour and a half. There's other wall types out there, folks. We didn't really cover masonry. We use brick or CMUs besides concrete, which are really all considered masonry products. Okay, I'll probably bring those in at a later time. Any questions or comments? Okay, draw them at the sizes we talked about. Please do not hatch them. I did bring in some other drawing sets. I put them on the back board. If you want to see, this person that draws these draws by hand, and you'll notice all his walls are hatched as a finished condition. Really kind of nice pieces of work. It also gives you, I think there's 4 or 5 house plans there, so you might have, if you're wondering how big to make a bathroom or a half bath, you're going to find it in there. Okay, besides your text, great place to look for that information. Okay, thanks for your time. Rest of the day is yours.